Hi everybody, my name is Mason, and today I'm going to be talking about ionization energy and electronegativity. Hope you learned something about that today. Ionization energy is the amount of energy that it takes for an atom to lose an electron, thus becoming ionized. Elements in the alkali metal family need very low energy to ionize, as they only have a single electron in the outer shell, causing them to be unstable and give away the electron very easily. This can be seen in an element like lithium, who has one full shell and then one shell with only one in it, causing it to be very unstable, wanting to give this away to become an ion. This gives it a very low ionization energy because it only has one in its outer shell. Also, if you have a bigger element in this family, like cesium, and it has a few full shells, a lot of them, but then in its outer shell, it only has one to give away. It's going to be having almost zero IE, because this electron is so far away from the center that the magnetism affecting it is very low compared to if it was closer, causing this to go away from the atom very easily. Next up, we have electronegativity. This is almost the opposite of ionization, being a measurement of how good an atom is at taking an electron from another atom. Elements in the halogen family, especially those towards the top of the table, will have a much higher electronegativity because of their single missing electron in the outer shell. Fluorine has one of the highest electronegativity numbers because it's missing a single electron in its outer shell. See, if we see fluorine here, see it has a full shell here, but it is missing just one to become a full atom. So, because it's so close here, it's going to pull an electron very easily from another atom. But even though it is in the same family as fluorine, something like iodine, which only needs one more to complete its shell, it will not have as high an electronegativity number as its cousin up above on the table. That's because the distance between the center and the outside is very great. The pull of the center on the outer electrons is a lot less, causing it to not have as high of a number because it can't pull electrons away as good. Also, an element like iodine can't take an electron from another atom as easily because the charge of the electrons in its outer shell will repel the other atom's electrons, making it a lot harder to steal atom's electrons. They repel each other. Alright, thank you for listening to me today, and I hope you learned something new about these topics.
Hello, this is Noah speaking, and I will be teaching about ionic and covalent bondings. So first off, we'll start off with ionic bondings. Ionic bondings require both nonmetals and metal ions. So as of right here, got number A has one electron. Then we have B, which has multiple electrons, but one missing. And we have B. And A gives its electron to the B, which makes an ionic molecule. A good example of an ionic molecule would be salt. Ionic bondings are the strongest type of bond. Covalent are strong, but ionic are the top-notch strong. So for an ionic bond, you have, let's use sodium. And then we also have chloride. They just go together. So the strongest type of bond. A covalent bond, we use oxygen and hydrogen. They go like that. Ionic compounds are way more stable. Covalent compounds, they share between two elements. They do make a stable compound, but these two are way more stable. Ionic bonds form a structure called the crystal lattice structure. It kind of looks like this. Have this, then you got little ones right here. The unit cells, which is this one, consist of lattice points that represent the location of atoms and ions. Right here, this would be a chloride, a definition. And this one would be sodium, the smaller one. For covalent compounds, bondings, they're made up of two or more nonmetals. So you go here, oxygen, hydrogen, hydrogen. Two or more nonmetals. An example of this covalent bond would be carbon dioxide, what we breathe out of our lungs. They are quite strong. They do take a lot to break, but these bonds are still not the strongest type of bonds. Polar covalent bonds are electrons that are equally shared between atoms. So polar, non-polar. So polar would be HCl, OH, H. That would be a definition of polar. Non-polar, though, is much stronger. It's triple-stranded between all these. Sorry, double-stranded here. That would be a definition of nonpolar. Thank you for your time. I hope you learned some about ionic and covalent compounds. Thank you.
Hi, I'm Thomas. I'm talking about atomic radiums. So, what is atomic radiums? The atomic radiums of the chemical element is a measure of the size of its atom, usually the mean or typical distance from the center of the nucleus to the outermost isolated electron. Why does it get larger as you go left and go down? What are the largest and the smallest atoms? As the atom increases in atomic number, so more electrons and protons are added to the nucleus. The increased size of the atomic center causes the electrons to contract more toward the proton, which reduces the radius of the atom across each row of the periodic table, and the largest atom is Fr and He is smallest. What does it mean that electrons are shielded from the nucleus? How does it affect other periodic tendencies? Electron shielding refers to the blocking of the valence shell electron attraction by the nucleus. Due to the presence of inertial electrons, and electron shielding describes the ability of the atom inner electrons to shield this positively charged nucleus from its valence electrons. What moving to the right of the period, the number of electrons increases and the strength of shielding increases. Hope you can learn something. Thanks.